I recently tested the DeepRender codec against SVT-AV1, VVenC, and X.265 in a low-latency real-time encoding configuration. I published my findings in a detailed report that you can download from the Streaming Learning Center. In this video, I'll walk through the workflows I use for encoding, decoding, and playback. I'll also show you a comparison tool that lets you gauge the quality difference directly. DeepRender is integrated directly into FFmpeg. In this familiar command string, you can see it listed as DR codec, just like any other codec. Otherwise, this source file is a 5-second 1080p 30 file that we're encoding using a QP value of 43. We're tuning for metrics and disabling keyframes for low latency and outputting in 420. Let's run it and see the performance. Here you can see the encoder running at about 22 frames per second, just under real time. Here's a 720p version that, as you can see, encodes comfortably faster than real time. In both cases, once complete, we get a standard MP4 output ready for playback or distribution. Let's take a quick look inside using MediaInfo. You can see the encoder identified as DRDR. This confirms we've got a clean, standards-compliant file using the DeepRender codec. Next, we'll play this video in VLC Player. To play DeepRender files, we're using a VLC build provided by the company that includes the DR codec support. We'll drag the encoded file directly into the playlist. Here's a clip playing back in real time. This is a 5-second segment from the Netflix Tango sequence. Let's stop playback and check the file information. As expected, you can see the codec identified as the DeepRender encoder. This confirms proper decoding in VLC. Let's look at a longer file, Tears of Steel. I'll drag it in. Check the file information. And let it play. You can see and hear real-time playback.
Are you ready? Of course you're ready. You're a rock star. How's it looking, Barley?
We should have about 10 minutes.
Well, that's perfect. We're only one. All systems go. Yeah, you go. Go. Move your asses. Go.
Playback is working natively in VLC with no conversion or workaround required. Now let's decode the file to measure decoding performance. We're going to decode output.mp4, the 1080p version, to Y4M and send the output to RAM. This avoids disk I/O delays during testing. Let's run the decode and see how it performs. In this case, we're seeing 76 frames per second at 1080p 30 on a $600 Mac Mini with an MPU. When it comes to codecs, playability equals deployability, and DeepRender's NPU-based decoding is a huge advantage over AI codecs that require GPUs or custom silicon. In my report, I referenced a formal subjective analysis conducted by VABTech UK. These are the raw scores. They average out to a BD rate advantage of 46.43% for DeepRender compared to SVT-AV1. To let you explore the differences yourself, DeepRender built this comparison app. You can access it at eval.deeprender.ai. Here's the main interface. All the clips used in the subjective test are listed on the left, organized by content type. Once you select a clip, the app loads both versions side by side. DeepRender is always on the right, and you can choose which codec to compare DeepRender to here. SVT-AV1, X.265, VVenC, they're all available. These buttons let you toggle between low, medium, and high bitrate encodes for each codec. This checkbox lets you keep both codecs at the same quality level, or mix and match if you prefer. You can watch the video play at normal speed and the clips will loop automatically unless you stop it to compare frames. This slider lets you compare visually by hiding one codec and revealing the other. The green DeepRender logo up here lets you see which clip you're viewing. In this clip, With SVT-AV1 on the left and DeepRender on the right, you can see how much more texture and edge detail DeepRender retains. This tool gives you direct visual context to judge the results yourself, not just rely on metrics or graphs. DeepRender performed very well in limited use case testing while demonstrating outstanding usability and integration. Its NPU-driven playback gives it a leg up over AI codecs that require GPUs for decoding and over traditional codecs that rely on custom silicon. And you don't have to take my word for it, or even the findings from VABTech. You can gauge the quality yourself using the comparison tool. Overall, it's an impressive public debut for a completely new and fundamentally different kind of codec.